Welcome students, we are given this question 1 positive 3i raised to the power of 2 positive 3i, and we are expected to find the real part. Now questions such as this keep occurring in competitive examinations, so it is imperative that we know how to solve them. Now foremost, before we could try to solve this question, it is imperative to understand that if I have a complex number of the form z is equal to x positive iy, then this can be rewritten in polar form as z is equal to r times e raised to the power I theta, where r is equal to square root of x squared positive y squared, and the theta value can be found from tan theta being equal to y over x. Now, having obtained this, I'm going to rewrite 1 positive 3i raised to the power of 2 positive 3i as, using the law of algebra, a raised to the power m positive n can be rewritten as a raised to the power m times a raised to the power n. So this can be rewritten as 1 positive 3i raised to the power of 2 multiplied with 1 positive 3i raised to the power of 3i. Now 1 positive 3i, let me just use this space to calculate. Now this is a positive b whole squared, so I want to find what happens when I raise 1 positive 3i raised to the power 2. So this is going to give me 1 squared 3i raised to the power 2. Now this is equal to 2 times 3 is going to be 6i, and this is going to give me 9i squared, which is equal to 1 positive 6i. I squared value, we know the value of I squared is negative 1. It is also important to know the value of I cubed. We are going to encounter I cubed. I cubed is going to be negative I. So this is going to be negative 9. Now 1 added with negative 9 would give me negative 8 followed by 6i. So this is the value of 1 positive 3i raised to the power 2. So I'm going to place that negative 8 positive 6i multiplied with 1 positive 3i raised to the power of 3i. Now I'm going to rewrite this as raised to the power 3, and that is raised to the power I. I can very well do that. Why? Because if I have something like this, a raised to the power m times n, I can rewrite this as a raised to the power m, the whole is raised to the power n, or I can rewrite this as a raised to the power n, the whole raised to the power m, from the law of exponents. So now what I'm going to do is I need to find the value of this, right? So let me use this part of space. Now I'm going to use a positive b raised to the power 3 formula, which is a cubed positive 3 times a squared b positive 3ab squared positive b cubed. This is a formula I'm going to use. So I've got 1 positive 3i raised to the power 3, which is 1 cubed positive 3 times 1 times 3i. In fact, this is squared, followed by 3 times my a is 1, my b is 3i raised to the power 2, positive my b cubed is 3i raised to the power 3. Now I need to do some simplification. 1 cubed is 1. This is 3 times I. This is 1 squared. That's going to be 1. So 3 times 3i. So that's going to be 9i positive. I squared is minus 1, and this is 3 raised to the power 2. So that's going to give me 9. So I got a 9 here and a I squared there. So let me write that down. 3 times 9, my I squared value is negative 1, followed by 3 times I, this entire thing is raised to the power 3. So this is going to be 27. So, and I cubed value is going to be minus I. So this is what I've got. Now I can rewrite this as 1 positive 9i, 9 times 3 is 27, negative, so it's going to be negative 27, and this is going to give me negative 27i. I can add these two together, so this would give me negative 26, and this is going to give me negative 18i. So this is what I've got. So I can rewrite this quantity 1 positive 3i whole cubed with this. So this is going to be equal to negative 8 positive 6i times in place of 1 positive 3i whole cubed, I'm going to rewrite that as 26 negative 18i raised to the power I. This is what I've got. Now this is a complex number, right? So by definition I can rewrite this complex number as r times e power I theta, and r is going to be equal to negative 26 squared followed by negative 18 squared, right? Now if I were to calculate this, 26 squared, that's going to give me 676, added with 18 squared, that's going to be 324. Now if I were to add 676 and 324, 6 added with 4 is 10, and 7, 8, 10, and then 7, 3, 10. So I've got 1000. Now I can always rewrite 1000 as 100 times 10, and which is nothing but 10 times root 10. So this is what I've got for r. So let me have this in one corner. So I'm going to have an equal to sign. So this is equal to negative 8 positive 6i. I'm going to rewrite this entire quantity as r times e power I theta raised to the power I, which is equal to negative 8 positive 6i times, my r is going to be this quantity, 10 times root of 10, and I'm not going to write theta in the representation of tan theta, so that will complicate my solution. So I'm just going to retain theta as it is, and that is going to be, just retain it as it is, e raised to the power I times theta raised to the power of I. So this is what I've got. Now if I were to multiply these two components, so let me rewrite this in the space here. So this can be rewritten as negative 8 positive 6i times, this is raised to the power I, so I'm going to rewrite this as 10 times root of 10 raised to the power of I times e raised to the power I multiplied with I will give me I squared times theta, but I squared value is negative 1, so this is going to be equal to negative 8 positive 6i times 10 times root of 10 raised to the power of I, and this is going to be e raised to the power of negative theta, right? So I'm going to rewrite this again as negative 8 positive 6i times e raised to the power negative theta. Now this quantity, let me use the space here, this quantity 10 root of 10 raised to the power I can rewrite this using e raised to the power ln of 10 root of 10 raised to the power I, because the e and the natural logarithm, they get cancelled, giving me back this, right? Now this is nothing but, now if I were to have ln a raised to the power b, I can rewrite this as b times ln a, right? So I'm going to rewrite this as e raised to the power, I comes in front, I times ln of 10 times root of 10. So this is how I can rewrite. So what I'm going to do, in place of this, I'm going to substitute this. So this is going to be e raised to the power I times ln 10 times root of 10. Now what is this exactly? Now let me place a parenthesis. Now this is Euler's formula. E raised to the power I theta is nothing but cos theta positive I times sin theta. So I'm going to make use of this result. So if I were to make use of this result, this is going to be equal to negative 8 positive 6 times I times e raised to the power negative theta, and this is going to be cos of, in place of theta I've got ln, so I place a parenthesis, ln of 10 times root of 10 positive I times sine of ln of 10 times root of 10. So this is what I've got. So now the question comes to extract the real part and the imaginary part. So let us do that. So I'm going to be using, so clearly this has got no imaginary part, so this is going to be featuring the e to the power negative theta. Now what I want to do is I have to multiply negative 8 with this quantity. So let me have a parenthesis. So negative 8 times cos of ln of 10 times root of 10. This is one quantity. Now this is going to give me a imaginary quantity, just in case if the question wants imaginary part. So let me just place that also. So this is going to be I times, of course I got a negative 8 times sine of ln of 10 times root of 10. So that is one quantity, and then followed by 6i. So this is going to be I times of 6 times this quantity. So it's going to be cos of ln of 10 times root of 10. So I've got imaginary quantity there, and I squared is going to be minus 1. So it's going to be negative 6 times sine of ln of 10 times root of 10. Okay, so that is fair enough. So this is equal to taking the real part first. So I've got a real portion here, and then I've got a real portion here. So I'm going to rewrite this as negative, of course there's e power theta there, so let me place that, e power negative theta. I got a 8 there, and then I'm going to rewrite this as cos of ln of 10 times root of 10. And then if I were to take this part, so the negative sign can be taken out, so it's going to be positive, and e power theta will be featuring. In fact, I could have taken e power negative theta out. So that is going to be e power negative theta, and I've got a 6 there, so it's going to be sine of ln 10 times root 10. So this is my real part. This is the real part. Now for the imaginary part, I also need to have this e power theta there. So I got a negative I and a 6. So I would have to write this as positive I. I will write this as positive I, and then I will take in negative 8 times e power negative theta, and this is going to be, I've got two quantities of imaginary part here, so that would be sine. So let me write the first component cos. So it's going to be cos of ln of 10 times root of 10. So if I were to write the cos first, then probably I should place a positive sign and 6 there, because I want to write the cos term first. So followed by negative 8 times e power minus theta sine of ln of 10 times root of 10. So this is the imaginary part. Of course I can have one more step, negative theta out, and then place the negative sign. So this is going to give me 8 times cos of ln of 10 times root of 10. And of course if you want, you can always take on the common factors. So I'm just placing as it is, 6 times sine of ln of 10 times root of 10. So this is my real part. Of course, if the question requires you to obtain the imaginary part, then you can take the imaginary part. So that completes the solution to this question, students.